Hello, my name is Chongwon Lim. My contribution was coming up with the idea of the moving hourglass and implementing the 3D rotation calculations for the hourglass points X and Y based on the spinning donut example from the textbook. This project is a 3D hourglass animation displayed using ASCII characters. The program calculates 3D coordinates for each point on the hourglass and projects them onto a 2D screen. The brightness of each point is represented with ASCII symbols. The reason it moves is that the variables A and B control rotation around the X and Y axis. Each frame, these values are updated, causing the hourglass to spin smoothly on the screen. I specifically implemented theta spacing, circle X, and the X and Y rotation calculations, which determine the 3D positions of the hourglass points. These calculations create the smooth spinning effect you see. This concludes part 1 of my video. In part 2, I will open the code and explain the lines I wrote in detail. This is part 2 of my video. I will explain the hourglass code line by line. This declares the hourglass class, which contains the main program structure for the animation. The main method is the entry point of the program. The throws interrupted exception allows the program to pause safely when you use drag sleep to control frame speed. These lines define screen size, rotation angles, scaling constants, radius values, and angle step size. I implemented theta spacing to control the smoothness of rotation. A smaller step produces more points along the circular path, resulting in smoother and more natural rotation. This improves visual quality and prevents choppiness. Brightness store ASCII characters representing light levels for the 3D effect. Z is the depth buffer and B is the character buffer. They are listed each frame to prepare for drawing. These loops iterate through points around the hourglass. Theta controls the circular cross-section, while phi controls rotation around the vertical axis. Cosine and sine values are pre-computed for efficiency. This is the main part I implemented. Circle X and circle Y define the circular cross-section. X and Y apply 3D rotation. The combination of R1 times sine theta and rotation angles creates a narrowing in the middle. This forms the recognizable hourglass shape. By controlling these calculations, we control both rotation and shape, improving visual clarity and smoothness. Calculate steps and maps 3D points to 2D screen positions. Which ensures points closer of your ladder, reinforcing the 3D hourglass effect. Calculate luminance for each point to select the correct ASCII character. This shading with 3D rotation helps perceive depth and reinforce the hourglass shape. Prints the character buffer to form the current frame on the screen. And this code updates rotation angles for the next frame and pauses briefly to control animation speed. In summary, I implemented theta spacing, circle X, and X and Y rotation calculations. This controlled the 3D rotation and the hourglass shape, improving visual clarity and smoothness. The rest of the code handles loops, buffers, and frame output. This concludes part 2 of my video.